Section 2.2 is on conditional statements, and a conditional statement is a statement that can be written in the form of if P, then Q. And the conditional statement is made up of two different parts, the hypothesis and the conclusion. The hypothesis is the part P of the conditional statement that's following the word if. So the hypothesis follows if. The conclusion is the part Q of the conditional statement that follows the word then. So the conclusion is at the end of it after the word then. So for an example 1 here, it says to identify the hypothesis and the conclusion of each conditional. So our first example says, if a butterfly has a curved black line on its hind wing, then it's a viceroy. So we have to figure out what is the hypothesis and what is the conclusion. So the hypothesis from our definition above says it's following the word if. So the hypothesis is that a butterfly has a curved black line on its hind wing. Actually, I'm going to do it like this. The hypothesis is going to get a single line. And the conclusion, it is a viceroy, will get 2 lines. So back up here, hypothesis will be 1 line, conclusion will be 2 lines. All right, part B, a number is an integer if it is a natural number. So the hypothesis is following the if statement. So it's actually at the end of this sentence here. It is a natural number. Then our conclusion is the number is an integer. So we got to look for those if words and then in that statements. All right, example 2 wants us to write a conditional statement from each of the following. So part A says the midpoint M of a segment bisects the segment. So we have to make an if-then statement out of this. So we can say if the midpoint is M, then M bisects the segment. Then for part B, we're given this diagram here, and the tarantula circle is inside of the spider circle. So I could say if it isn't a tarantula, then it is a spider. So if it is a tarantula, not tarantulas, then it is a spider. One more vocab word here for today is the truth value, and that is a conditional statement has a truth value of either true or false. So for example 3, we have to determine if each conditional statement is true. If it's false, we have to give a counter example. Part A says, if today is Sunday, then tomorrow is Monday. That is true. We can't change the order of the days of the week, so this is a true statement. Part B says, if an angle is obtuse, then it has a measure of 100 degrees. The hypothesis is true, but the conclusion is false. Therefore, this is false. Because an obtuse angle does not have to be 100 degrees. It could be 110, it could be 170, it could be anything. So it's not, just because the angle is obtuse, it does not mean it measures exactly 100 degrees. So the measure can be any number between or greater than 90 but less than 180. So I don't want that between. And this one says, if an odd number is divisible by 2, then 8 is a perfect square. So is our hypothesis true? An odd number is divisible by 2. No, that is false. Then 8 is a perfect square, is our conclusion. 8 is not a perfect square. If we take the square root of 8, we're going to get a decimal, so it is irrational. It's not a perfect square. So that's false too. So this one's kind of different because if the hypothesis is false, the conditional statement, so this whole statement, is considered to be true regardless of the truth value of the conclusion. So if this is false, right here, if that if statement is false, then our whole statement is going to be true.